DynamoDB Streams captures a time-ordered sequence of events on any DynamoDB table. It is also referred to as change data capture. Whenever an application creates, updates, deletes items in the table, DynamoDB Stream writes a stream record with the primary key attributes of the items that were modified. A stream record contains data modification information of a single item in the DynamoDB table. DynamoDB Streams helps decouple application logic with the effects that happens afterwards. Some common examples include replicating your data, generating read models, and also it can be used as an alternative to transactions when you need to update multiple sources of data. In this video, let's get started with DynamoDB Streams, learn how to create and enable them on a DynamoDB table, also learn how to interact with the stream records and events that gets written into DynamoDB Streams. We will use AWS Lambda built with .NET Core to react to the stream record events that happens. We will also learn the different configurations associated with this Lambda trigger, handle exceptions, and also different patterns of integrating with DynamoDB stream records. Hello everyone, welcome back, and my name is Rahul. If you're new here, I make videos on .NET, Azure, AWS, and DevOps. Without much delay, let's get straight into learning all about DynamoDB Streams. DynamoDB Stream is a time-ordered sequence, and it also stores this information in the log for 24 hours. DynamoDB Stream guarantees that every stream record appears exactly once in the stream. And it also makes sure that every item modified in the table, the stream record appears in the exact same sequence. This is why it is referred to as a time-ordered sequence. So as you make changes to your table, you will see these sequence of events inside your DynamoDB stream. AWS maintains separate endpoints for DynamoDB and DynamoDB Streams. So when we enable DynamoDB Streams on a DynamoDB table, a new separate endpoint is getting created. Now you can either enable the DynamoDB stream on an existing table, or you can also set it up while you're creating the table. Now in AWS console, it supports enabling it only after creating the table. But if you're using CloudFormation scripts, you can enable the DynamoDB table stream even when creating the table. In this case, let's navigate to my AWS console, navigate to DynamoDB, and navigate to the tables section. Here I have an existing table, that is the user table, that I have been using in my API gateway videos. Let's navigate to this. Under the table details, in exports and streams, there is an option to enable DynamoDB stream. So the last option here says capture item level changes in your table and push the changes to DynamoDB streams. By default, this is disabled. Now you can choose the enable button to enable the stream. Now when enabling, you can choose the different data that gets part of the DynamoDB stream. With the key attributes, only the key attributes of the item that is changed is captured. That is the hash key and the sort key if you have one. If you choose new image, the entire item as it appears after it was changed. That is the new item that gets saved or the data that was modified. You can also choose just the old image, which is the data that was before modification. Or you can also choose new and old images. So if you're choosing new and old images, all the information before and after will be available in the stream. For this example, let's choose with that and get going. But based on your needs of your application and the scenario that you're building for, make sure to choose the appropriate type. So let's enable the stream, and this enables the stream on this DynamoDB table. You can see the information here, and it has created a new stream ARN for this DynamoDB table stream. We will be using this to give permissions for Lambda functions to access the stream. With the stream created, we can now associate Lambda functions that gets triggered anytime a new item comes into the stream. For this, we need to make a Lambda function. So let's head over to Visual Studio and create a brand new Lambda function. I'm using the same solution that contains the Lambda functions for my API gateway endpoints. I have been building an API gateway using Lambda integration in some of the previous videos. You can check out the links in the description below. In here, let's add a new project and create a new Lambda project. So let's click New Project and select AWS Lambda project. Now these options are coming because I have AWS Toolkit installed in my Visual Studio. So let's click Next, which prompts us to give this a name. So let's give this a name as User Stream Trigger and click Create. Now this prompts us to select a blueprint. You can either choose the empty function and set it up yourself, or you can directly choose the simple DynamoDB blueprint. This is a skeleton for Lambda function to get started responding with DynamoDB stream events. So most of the code will be automatically set up for us. So this has created the new project, and it has also added the function.cs file. Inside here you can see this is already having a function handler which takes in the DynamoDB event. This is the class that represents the stream event that is written into the DynamoDB stream. Now in here, if you expand the dependencies and packages, you can see a couple of packages are already added. That is the DynamoDB2 and the DynamoDB events. These are the NuGet packages from which we get these types. The core and the serialization comes automatically in the default empty project as well. So let's collapse the Solution Explorer and see what this function is doing. In here we get the DynamoDB event. So if we navigate into that, you can see it consists of a list of records, which is of type DynamoDB stream record. That is also contained here, which further inherits from the record type. If we further navigate into the record type, we can find the different properties that's available here. Now the important one is the stream record, which is of DynamoDB. This has the new image, the old image, and the keys properties. Now based on the type of the stream that we had enabled, the different options we saw just now, the different properties will be populated. Now if we have selected just the keys, the new image and the old image would be empty. But in our case, since we selected new and old, all these properties will be populated. Now your application code will need to check for nulls in these and handle appropriately. So let's come back to our function.cs, and inside here it loops through the records in the DynamoDB event, and for each record it simply writes the event ID and the event name to the log. Now when you use the context.logger, if you have CloudWatch set up, it will automatically get logged into CloudWatch. Now if you're new to CloudWatch, I have a video which covers all the details on that, which will be linked here on in the description below. Now let's publish this Lambda function onto my AWS infrastructure and set this up with the DynamoDB stream trigger. To publish this, I will use the Visual Studio Toolkit. So let's right click on the project and say publish to AWS Lambda. Now I already have the AWS credentials set up, which enables this to connect to my AWS account. Now if you are new to this and want to learn how the credential management works and how to get all of this working locally, you can check out my video linked here or in the description below. Now let's give this a name. So let's call this as user-stream-trigger. The handler name in this case is pointing to the wrong project. So let's fix this. So this should be user stream trigger, which is the assembly name. So let's replace this with user stream trigger. And inside this should be user stream trigger as well, which is the namespace name. This appears to be a bug with the AWS toolkit when there are multiple Lambda projects. So let's name this as user stream trigger. Rest of the things remains the same because this is the function class and the method name is function handler. So once that is fixed, let's click next, which prompts us to select the role that this Lambda should have. So let's scroll down and let's give the Lambda basic execution role, which provides permissions to write to CloudWatch logs, and click upload. This uploads this new Lambda function into my AWS account. Now, if you're completely new to building Lambda functions, I have a video linked here which gets you started as a .NET developer. I also have a Udemy course if you are interested to learn more about building Lambda functions. All the details will be there in the description below. Our Lambda function is successfully published. So let's go to our AWS console, navigate under Lambda. So let's open this in a new tab and go to Lambda. Under here, we can see 3 Lambda functions. The user stream trigger is the latest that we have just deployed. Let's add a trigger for this Lambda from our DynamoDB stream. So if we click the create trigger and select the new function, which is the user stream trigger. Let's select the batch size as 1, which means the number of records that the Lambda reads at once before invoking the function. So as soon as there is one record, in this case, it will invoke our Lambda function. So let's click Create Trigger. Now this is going to throw an exception because the Lambda cannot access this stream that we are trying to add it to. So let's first give the Lambda function permissions to talk with this stream. So let's copy this ARN of this stream. So let's copy the full ARN, which we can also do from the previous page if required. Let's come into our Lambda function. Let's go into configuration. Under permissions, let's go to the role name that was created. Now this by default has the Lambda basic execution role, which provides access to the CloudWatch. Let's also give this permission to talk to our Lambda stream. In this case, let's go to add permissions, create inline policy. Let's choose a service, which is DynamoDB, and let's select the actions. Now, if you look at the previous exception, we can see this requires the get records, get shard iterator, describe stream, and list stream actions. So let's navigate back. Let's go to the read. Let's enable these options. So this has describe stream, get records, get shard iterator, and list streams as well. So let's come back and select list streams. And let's also specify the specific ARN that this should have access to. So let's click the add ARN and let's paste in the ARN that we have just copied, which is the specific ARN for this DynamoDB stream. And click add. Let's review the policy. Let's give this the name user stream trigger policies. And let's click create policy. This creates the policy and gives the Lambda function all the access that it requires to talk to the DynamoDB stream. So if we come back to our create a trigger and click the create trigger again, this time it is successful because the Lambda function has the appropriate permissions to talk to this stream. So if we scroll down, we can see the triggers that's already associated with this DynamoDB stream. Now, with that setup, let's make some changes to our DynamoDB table and see if this integration is successful. So let's navigate to the tables in a different window and let's go to the user table. Let's go under Explore Table Items and edit one of these items here. So if we go to the Lambda function, you can also go to Monitor and go to View Logs in CloudWatch to see exactly what is happening. Now, right now, there is no log group created because the Lambda function was never invoked. Now, if I come back to items and let's open one of these items and edit the user name. So let's give this as Lambda trigger and save the changes. Now, as soon as we have clicked save, this would have created a new stream record inside the DynamoDB stream, which would then trigger our Lambda function. And that should have ran and logged it inside the console. So let's refresh this CloudWatch logs and we have our first log stream in here. If we open that, we can see there is the modify event and the event ID is this. And it also processed one record. Now if we come and edit it multiple times, so we'll have to refresh this so it fetches the latest item. And let's make one more update and click save changes. And if we refresh here, we should be able to see the logs as soon as the Lambda processes it. Now there is a slight delay on the logs appearing here, but you can see here now it says beginning to process one records. This is again a modify event. Now I have an API gateway API that I have built in the previous videos, which talks to a Lambda function and writes records into this table. So let's use that to invoke and see if this integration is working fine. Now I have Postman here, which is a utility that you can download for free, which allows me to post requests to this API endpoint. Now this API endpoint is wired to an AWS Lambda, which talks to this same user table. So let's come here under the body, let's create a new user. So let's give this a random ID as the ID and let's say from Postman and click send. Now this talks with AWS API gateway. It then connects to a Lambda function and writes to the DynamoDB table. It's given back the message user added, which means the user is successfully added. So if I refresh here, you can see the Postman record that we have just added inside the table. Now this would have triggered another event. So if we navigate to the CloudWatch and refresh, we should be seeing a new item. So in this case, it says the event name insert because it's inserted a new record. Now if you want to learn how I built this API, you can check the video linked here or in the description below. Anytime when building this application, you can also test it locally inside your developer environment. So if you navigate to Solution Explorer, right-click on the stream trigger, and let's make this as the startup project. Now you can see there is a mock Lambda test tool automatically wired up with the Lambda projects. So if you press F5 or run this application, this is going to run a mock Lambda test tool. From here, you can invoke events and simulate DynamoDB events. For that, let's expand this example request. From here, let's choose the DynamoDB update event. This gives us a similar JSON structure of the event as it would have happened. Now, if we click execute function with a breakpoint in here, we will see that this breakpoint gets hit as expected. You can also loop through the different records inside this event. So in this particular case, this has 3 events, and this Lambda function is processing all the 3. Now, when we set up the integration, we set it as 1, because of which every time we just get 1 record. But that's something you can update, and we will see a while later in this video. So let's run this, and you can see all the records gets written inside the console as well. With the basic Lambda function setup to handle the DynamoDB event, let's explore how we can use the data inside the DynamoDB event. Right now, all we are logging is the event ID and the name. But what if we want to know the details of the actual object that was changed, what was before and after? Let's see how we can do that. Now inside the record, we saw that the record has the property DynamoDB, which has the old and the new image. So we have 2 properties from which we can get the values of this particular event. Now by default, the old image and the new image are properties which is of type dictionary of string and attribute value. This is the low-level DynamoDB APIs, but we want to access this as a rich user object so that we can interact with the data that is coming back. Now we can convert this type into a user object, which we know is what is being triggered by using some DynamoDB methods. So let's exactly see how to do that. Now if we navigate back to our function, which is the AWS Lambda, we can get the actual user object. So if we scroll all the way down in my solution, we have a user object here. So let me copy and paste that into this class as well, so that we have the user object. Now in a real application, you might be sharing assemblies so that you can share these models. Now with the user object here, let's come to our function and let's also create a new instance of the DynamoDB context. So let's say context is equal to new DynamoDB context and include the appropriate using statements. Now this NuGet package is already added, so we don't have to explicitly add anything new. This expects a new Amazon DynamoDB client, so let's also pass that inside here. So let's use the appropriate usings and pass this client. Let's create this new object inside our Lambda function. So let's generate the field context. Now we can mark this as read-only because we're not going to update this. Now with the context created, we can use that to convert this old image into the user type. So let's first use the class document, which is coming from the Amazon DynamoDB document model, and use the from attributes map to convert this into a document model. So let's pass this the old image, which gives us the document model for this DynamoDB item. So let's capture this as document. Once we have the document, we can use the context class and use the from document, specify the type, in our case user, and pass in the document to get the user object. This is the way that you can convert this dictionary type into the actual user. You could also write this as an extension method so that it becomes easier. Now in this case, let's say this is the user. So we get the actual user, which was the old image. Now if we want, let's also navigate and refactor this into a new method. So let's say this is the get user object method. So let's fix this and let's make this as a dictionary of string attribute value type. So let's make this as dictionary of string attribute value type and give this the name as image. So any image that you pass into this, we can convert this as a user type. You can also make this generic and make it for any type that you require. So to do that, let's give this as a generic type of T, and instead of specifying user, you can simply use T in here. Now this is going to return this generic type. So let's say return and make this as T as well. So this simply takes in the T generic type, uses the image, converts it into the document first, and then it uses the from document and returns that object. Now since this is a generic method, let's simply make this as get object. And let's call this from here. So let's say get object of user, and let's specify the record.dynamodb.old image. Now in this case, let's get this as user. Now we can write this into the log. So let's say context.logger.log information and write the old user. So let's use string interpolation and let's specify old image and let's write this user object. So let's use the JSON serializer and serialize this as a string. So let's pass in the user and let's close this string and end this function. So this is going to log as an old image this user. Now similarly, you can also get the new user. So let's write this as a new line and let's, instead of using the old image, specify the new image and write this as the new image. Now this successfully logs the before and after of the DynamoDB item that was being updated. Now let's make sure this is successfully building and let's publish this to our Lambda function. So let's right click and say publish to AWS Lambda. Now this has the appropriate details, so let's simply click upload. Now this is going to replace the Lambda function in our AWS infrastructure. So now if we come back to our Postman, let's create a new object. So let's say new logs with images and click send. Now this is going to add a new item to our DynamoDB table. So if we come back to CloudWatch, let's come back to the triggers and let's refresh this because there will be a new stream that gets created. So we have the new stream. This new stream was created because we published a new version of the Lambda. So let's click that and you can see the full information inside here. Now here we have the old image and the new image as well. In this particular case, all the values of the old image is null because this is a new item. So you can see the type as insert here. Now the new image has the details of the object that we just created. Now if we were to come back to the items and update an existing object, so let's update this from Postman and let's say updated and let's click save changes. Now if we come back again to CloudWatch and refresh this, we can see that object is now processed. So you can see the old image as from Postman and the new image has from Postman updated. So we are able to get the before and the after of that same object when that activity happened. Now you can use this information inside your Lambda function to make the decision that your application wants. You could raise domain events which says username changed or do whatever is appropriate for your application scenario. If we navigate back to a Lambda function and refresh this, we can see there is a trigger that's associated with this Lambda function now. This is the DynamoDB trigger that we have set up using the streams. Now if you click this, you can look at the triggers list and you can also edit the options. So let's select the details. Let's select this checkbox and let's click edit. Now you get more options to update on this trigger. You can see the batch size is now by default selected to 1. Let's update some of these properties and see the behavior change. So instead of batch size 1, let's make this as 2 and let's give the batch window as 30 seconds. Now the batch window is the maximum amount of time to gather records before invoking the function. So anytime the Lambda function looks at the stream, it will wait for 30 seconds to reach this number of batch size. So if in this case, since we have given it as 2, if there is a record that updated, it will wait for 30 seconds to see if there is one more to come and batch them and send it to our AWS Lambda. Now if 30 seconds is passed and only one event is there, that event gets delivered to our Lambda function. Now based on your application, you can choose these configurations as required. So let's update this and see this in action. So now if I come back to our CloudWatch, let's clear off all these logs so that it creates a new log stream. So let's click delete and delete off all the logs. Now let's come back to our DynamoDB items and let's open this into different tabs. Now we have two items that is opened. So let's remove the new log with images and let's save these changes. Within the same 30 seconds, let's also make an update to another item and click Save Changes. Now if we come to our CloudWatch and refresh here, there is a new log stream created. So if we navigate into that, this time you can see this is beginning to process two records. So it has got both the records in that same 30 seconds window and processed it inside that single Lambda function. Now if we come back to our function, you can see this loops through all the records that comes into our function and processes it independently. Now if I was to come back to the items and let's open this again, and if we simply make update to one item, so let's say updated, and wait for 30 seconds, this item will also be delivered, but only one record will be there in that event. So once the 30 seconds is passed, let's come back to CloudWatch and let's refresh this to see that record. Now in this case, you can see there is processing one record and it has that object that we just updated. So in this case, since the 30 seconds passed, it just gave us the one record that was already present in the stream record. It did not wait for two records to appear. Now at times, we might want to filter the events based on some conditions so that we don't want to process all the events that comes into the stream. So if we come and edit the integration, so let's go to the Lambda and click edit the integration. And if you expand the additional settings and navigate to the bottom, you can specify a filter criteria. You can add a filter criteria as required. So if you click the learn more, you can see the documentation on how to apply the filter criteria. So you can specify specific conditions based on the properties inside that stream record events. Now you could choose to process the events only if it's for a specific user or specific roles or specific numeric conditions that gets met. Now this is completely different based on your application need. So I'll leave you to figure this out from this documentation that's attached here. Now all you need to do is use these filters and apply it inside this UI. Once that's done, the Lambda function gets invoked only if it passes the filter criteria. Until now, the Lambda function was processing the records successfully. But what happens when there is an exception inside the Lambda function? Let's see exactly that. So let's come back to our Lambda function and simulate an error condition. Now this error might be due to talking to an external service and that is down, or it could be even because of some processing logic because we haven't handled some of the cases properly. So let's simulate an error condition in this case. Now when we have the user object, so let's add in a condition user object is not equal to null, and let's also check if the user dot name contains the value error. Now anytime we are going to add the value error inside the user, this is going to throw an exception. So let's simply add a context.logger information. So let's specify context.logger.log information and let's specify user contains error. And let's throw a new exception in this case. So let's say user contains error as well. Now since we are already null checking here, let's remove this user not equal to null in this case. Now since this is a nullable boolean, let's give this a default value, which will be false. So if this value doesn't pass, it will just ignore this. So if the username contains the error, it's going to throw this exception. So let's build this and deploy this into our Lambda function. So let's right click and say publish to AWS Lambda. Now I'm simply using this to simulate an error condition. In your real life, it might be talking to other services or some business logic errors inside your code. But let's see what happens when an exception is thrown. Our Lambda function is successfully deployed. So let's come back to our CloudWatch logs. Let's clear off all these logs so that we can clearly see what is happening. Now our logs is empty. So let's edit one of these items and let's add the value error. This is going to throw an exception because the name contains error. So now if we come back to the CloudWatch and let's refresh this, and we have the new stream record. So let's open that And here we can see now there is errors inside our processing. So it has taken the old image and the new image, and this has seen that it contains the value error and it throws the exception. This forces the Lambda function to error out, which breaks the integration with the Lambda stream event. Now anytime the Lambda function throws an exception, it considers as not processed. So it retries that message up until it successfully passes. Now in this case, you can see this has processed a couple of times already. Now this keeps sending the message every time we make an update to any of the items. Now since the Lambda stream is a time-based and ordered series of events, it waits for this item to get processed before any of the new items gets delivered. So even if I was to come and open another item from here, and let's say I updated it, so let's make this as Rahul Nath and save changes, this item is not going to appear inside our logs until we fix this error that's existingly happening on that stream record. So if we refresh this logs again, we still don't see the new item. So you can still see the last processed one was the updated error. And this is still inside the queue. So if I was to delete these logs, and let's say I come back here and update this item again. So let's say Rahul Nath updated and save the changes. We can see soon there will be a trigger on this stream from the Lambda function, but that would still be reading the first item which has the error. Now you can see there is a new log stream, so let's navigate into that, and you can see this is still getting delivered the updated error 1. Now only once this is successfully processed or removed from the stream will the new records start appearing. So how do we handle for this exception? So if we navigate back to our Lambda function and navigate to the integration properties, so let's go to the trigger and let's edit this, we can see there is an option in the additional settings to specify a queue or a topic ARN. Now the Lambda discards records that are expired or fail all retry attempts into this queue. So this acts as a dead letter queue for the DynamoDB stream events. So in this case, we'll need to specify a queue here. So let's navigate to a different window and let's create a new SQS. So let's navigate to simple queue service and let's create a queue. In this case, let's give this a name as user trigger DLQ to stand for dead letter queue. Let's give all the options as default and let's click create. Now if you're completely new to Amazon SQS, I highly recommend checking out my video linked here, which helps you get started. So let's copy this ARN for this queue that was just created. Let's come back to our trigger and paste this ARN in here. Now inside this, we have two options. We can either give the maximum number of retry attempts, or we can also give a maximum age of the record. Now based on these options, if it has passed this criteria, this will be moved to the dead letter queue and the next item will be picked up from the stream. Now right now, since it is -1, it has the max limit, which means it has to be processed. So let's update this value to be 2, which means the maximum number of retry is 2. So with this 2, let's click save, which again prompts us another error because this Lambda trigger does not have permissions to call send message on the SQS. So we'll need to make sure this permission is added to our Lambda function. This is exactly similar to when we set up the DynamoDB stream trigger. So let's navigate to our IAM console here and let's add a new inline policy. In this case, we will be giving the permissions to talk to this SQS. So let's search for SQS. Let's specify the property that it needs. So this is write and let's select send message. So this has access to send a message to this queue. Let's also specify the ARN for the queue. So let's specify the full ARN that we have copied and let's click add. And let's click review policy. In this case, let's specify user trigger DLQ policy and let's click create policy. This provides the Lambda function access to send message to the DLQ. So if we were to come back to here and click save again, this time it should go in successfully. To trigger a processing on the item, let's navigate to one of the items inside here. Let's refresh this. And let's update this again and click Save Changes. Now this is going to trigger a stream activity, which is going to again trigger our Lambda function. So let's come into our CloudWatch. And here you can see this has retried a couple of times already. So you can come into the SQS queue. Let's go to send and receive messages and let's poll for messages. Now you can already see there is an item moved into this queue. So if we click this, we can see the properties of that particular object that was erroring out. Now we have the stream information here, using which you can fetch the item from the DynamoDB stream. Now if we go back into our CloudWatch logs and let's refresh these logs and let's go into the latest log stream. Now here you can see there is beginning to process 2 records and it has got all the updated ones that we had since done. Now you can see all the values are getting updated here. Now if I come back to edit the item and make updates again to these items, so let's remove these double updates and let's click Save Changes. Let's also edit another item. Let's remove that error from here so that this is no longer erroring out. And let's come to our CloudWatch and refresh these logs. Now in this case, you can see both the records being picked up. So the again was removed and also the error was removed from here. Now if we clear the entire logs and if we come back to an item and let's update this again with error and let's save this to see what happens. Now if we navigate back to CloudWatch and refresh these logs, here we have the new log stream created. So if you navigate into that, now you can see this was processed the first time and then we have the first retry and then we have the second retry. After that, this message does not appear inside the logs. So if we navigate to the SQS and if we refresh this for messages again, we will see 2 records inside here. So after 2 retries, it moves that into this dead letter queue and the new updates will be available for processing. Now based on your application needs, there are different ways you can process Lambda stream events. Now there is a good article from the AWS blogs which goes through these different options. So if you scroll down, you can see the basic option that we have looked at right now, which is whenever we have a DynamoDB stream and the events gets picked up by a Lambda function and it does some work. In our case, we were simply writing it to a log function. You could be invoking to another Lambda function, or you could be writing to a DynamoDB service, or you could also be talking to external third-party services. Now in these cases, there are some pros and cons for using this model. One of the things that we clearly saw was how to handle partial failures. Now, another option would be to use an SNS queue automatically in between. So instead of doing any processing in your Lambda function, you will simply push this into an SNS. You could also use an SQS queue depending on your use case. Since there is minimal processing happening in the Lambda function, the chances of it erroring out is very minimal. All you would be doing is simply get the message and publish it directly into an SNS queue. This makes the message available for retries and future processing immediately. So you can have different subscribers for this SNS and do different processing based on your application needs. Now the other option this suggests is to use a Kinesis stream with Lambda function. I'll make sure to put a link for this blog post in the description below, which you can use as a reference. I hope this helps you to understand more about DynamoDB streams, how to create and set them up, and also how to integrate Lambda functions with it. We've seen the different properties that gets populated in the stream record and how to access them inside our function. We also learned about error handling and also how to use an SQS in our case to handle the error messages. In a future video, I will be using the DynamoDB streams capability to implement the outbox pattern, which is a popular pattern when you're building disconnected applications. If you like this video, please hit the like button. If you have any feedback, questions or comments, make sure to leave them below. Also, don't forget to hit the subscribe button because it helps me to grow this YouTube channel. Thank you and see you soon in the next video.